Okay, for this question, right, we are given that the weight of the block is Q. So that means the block is exerting a downward force of Q on the table. And because of Newton's third law, action-reaction force, the table is going to apply the same force on the block, which is also equal to Q. Okay, so if I want to calculate the pressure exerted on the block by the table, pressure will be equal to the force over the area of the block, and the force here will be Q. The area will be the area of the base area of the block, and that will be X. So that will give us the answer as A. And we find that the weight of the table R is given in the question. Actually, this information here is meant to mislead the candidates. Okay, we understand that a fish is swimming below the surface of a lake. So let's represent this with a diagram. The fish is at a depth of 8 meters. So you can see that the fish is experiencing both the atmospheric pressure as well as the pressure of the liquid column. So to find the total pressure experienced by the fish, it will be just adding up the atmospheric pressure and the liquid pressure. So atmospheric pressure is 10 to the power of 5, and then we plus the liquid pressure, which can be calculated by H rho G. So it will be 10 to the power of 5 plus 8 times 1000 times 10. This will give us a total of 1.8 times 10 to the power of 5 Pascal. So that will give us the answer D. Okay, there is a ball at a height of 2 meters on a slope. So definitely this ball will have gravitational potential energy, and it has a speed of 3 meters per second. So that will give it some kinetic energy as well. So as it rolls to the bottom, we find that the height becomes 0. So all the energy that it has will be just kinetic energy. Okay, so with this, we can say that the kinetic energy at the bottom is actually equal to the gravitational potential energy and the kinetic energy when the ball is at a height of 2 meters. So we can calculate it as this way. Ke is equal to gravitational potential energy at 2 meters plus the kinetic energy when the ball is moving at 3 meters per second. Okay, so let's calculate this. Gravitational potential energy is equal to mgh, so it will be 0.4 multiplied by 10 multiplied by 2, and the kinetic energy is half mv squared, so it will be half times 0.4 times 3 squared. So the gravitational potential energy will be 8, and the kinetic energy will be 1.8. So the total energy that it has at the bottom of the slope, it will be 9.8 joule. So that will give us the answer as D. Okay, to find the power that is developed by the students when they are climbing the stairs, we can try to visualize the scenario. So we have a student who is trying to climb up a flight of stairs. Okay, and in order to climb up, the student has to apply a force that is equivalent to the weight so that it can bring up the body. And let us assume that the height of the stairs is represented by D. We can express the power as work done over time, which is equal to the force times distance over time. Okay, so now we can calculate the power that is developed in the 4 cases. A in another column as power. Okay, for A, right, the weight is 300 and the time taken is 10. So using the formula, power is equal to force times distance divided by time, we should get 30D for option A, 32.5D for option B, 28D for option C, and 30.6D for option D. So we have the answer as B because it has the highest power developed. Okay, for this question, right, a candidate will require quite a strong conceptual understanding in thermal physics to solve the question. And the question can be divided into two parts. Okay, first of all, the piston is being moved outwards slowly and the volume of the gas increases. So as the volume increases, it will actually pull the particles apart. So the particles of the gas will be further apart, and when they are further apart, there will be lesser collision. There will be lesser collision with the piston wall, and this will bring about a lower pressure. So only option A and option B are correct at the moment. Okay, then the second part, it says that the internal energy remains unchanged. And for internal energy, there are two components. The first component is potential energy, and potential energy depends on how far the particles are away from each other. So the larger the spacing between the particles, the larger the potential energy. So since the particles are being pulled further apart, the spacing between them will increase, so the potential energy will increase. And the second component will be kinetic energy. Okay, so since potential energy increases and the internal energy must be constant, so that with that we can say that the kinetic energy has to decrease, and kinetic energy is related to temperature. So if kinetic energy decreases, the temperature must decrease as well. So we have the answer as A.